I want to walk you through this lab so that you'll have some good results. You're learning some new skills and you're practicing them, both doing a vector diagram analysis and then also doing analysis analytical and then comparing the results. Here's the setup. The screw that's hanging down on the string marks the point at which the little ball will leave the ramp and also the point at which the collision occurs. It's really important to mark that spot on the paper. It's also really important to tape the paper to the floor and tape all the sheets together so that you can lift the whole thing off to do the analysis. So you let your ball fly off the ramp from the top. The paper on the floor is covered with carbon paper. As the metal ball lands on the carbon paper, it leaves a dot. And then you remove the carbon paper, circle the dot, and with a meter stick connect the two dots, the place where the ball left the ramp, the little orange dot, to where it landed. This distance in centimeters will allow you to calculate the velocity of the ball as it left, the horizontal velocity as it left the ramp. All you need to do is calculate the time of the drop, which will remind you about later on. Now you're going to do it again. You set the second ball on the screw there for the collision, and you put the first ball back at the top of the ramp and you let it go. It's going to hit and the two balls are going to go off at an angle and hit the paper on the floor. Don't forget to put your carbon paper down, and once you have all your results, you're going to change that angle. It swivels around so that your partner can try it again and will get slightly different results. So the collision has occurred. The first ball that you've used twice now have hit the paper. I've circled the place where they landed with the circles. And then you draw from that place where the collision occurred again, the original dot, you connect it with a straight line ruler. And those lines can be measured. And they will also give you the velocity of each of those two balls, which you can see is less and it also on an angle. So you need to record the angle. The line, the original line of the original ball, first ball that flew straight off, no collision, that becomes your reference line. You can measure the angle with respect to that line. The more accurately you measure everything, the better your results. Here's a reminder of the calculations. So we really ultimately want to know the momentum of the ball as it comes off the ramp. Momentum is a product of mass and that velocity. In this case, it's velocity x, only a horizontal component. So to get Vx, we have dx. And to get time, we can measure with a ruler the drop, the distance that the ball falls down from the point at which the collision occurs right to the floor, so dy. So you know dy, you know a, you know dx, and you can calculate the time and then the horizontal velocity. Go back to your data table, enter those lengths in centimeters, convert them into momentum by multiplying by the mass of the ball. You've weighed each of the balls. Don't forget to keep track of which ball's which, especially if the balls are slightly different mass. So what we really want to know is how does the momentum of that first ball, just before it hits the second ball, how does that compare to the momentum of the two balls after the collision? So we can do it by drawing the vectors, and we can do it by doing the algebraic components, the component method. So momentum is a vector, so that's how we're going to draw them. The red line is the momentum of ball 1 before the collision. It's your reference line. I'm going to call it my x-axis. And then I'm going to draw the momentum vectors for the ball 1 after the collision and add to it the momentum vector for ball 2 after the collision. Show the angles. You're measuring everything to scale. Calculate your scale ahead of time. You want to fill the whole paper. And they probably won't be the same. And so the difference there, the difference between the red line and the blue lines, is your error. To do the algebraic analysis, make a table for the vectors ball A or ball 1, ball B or ball 2. X, as shown in the vector diagram, is along the original before vector. The total should be just in the x direction for before. and then the after, and you're looking for components, and you create this green summation of the vectors vector. The difference between that before vector and the after vector is your error. The lab is asking you to examine the energy before. Now, before they collide, only one ball is moving, so there's kinetic energy of ball 1 or ball A. And after the collision, both balls were moving, so these are horizontal velocities that affect or add to kinetic energy of A and kinetic energy B. And lastly, you're going to examine errors, and the most significant error in the lab that I can think of is whether the balls are hitting square on or whether one glances off the other, because in the latter situation, that'll affect the trajectories. The trajectories will be different than if they hit square on. Good luck.